Okay, in this video we are doing Calc AB Problem Set 93. The problems and the playlist are in the description below, and let's take a look at the problems. So number one, the velocity of a particle is given by v of t equals 1 over 1 plus t squared with s of 1 equals 3. You can tell that I kind of edited the problem on the fly there. I had a number that just did not work out in another part, so I changed it to 1. We're good to go. Is the speed of the particle increasing or decreasing at t equals 2? We know that to talk about speed increasing or decreasing, we need to know velocity, we need to know acceleration. So first up, because we're given velocity, I'm going to find v of 2. So v of 2 is just plug in 2, right? 1 over 1 plus 4, so 1/5. To get acceleration, what I'm going to do is first, I'm definitely going to say that a of t is equal to v prime of t, because that is required if you want to get all the points. I'm going to think of the velocity as the quantity 1 plus t squared to the negative first, so that I can just kind of like power rule, chain rule this thing in my head instead of kind of thinking of the quotient rule. So it's going to be bring down the exponent, 1 plus t squared to the negative second, and then times 2t. We just need to evaluate this at t equals 2. So when we plug 2 in, we're going to get, I don't know why I'm saying 2 funny, we get negative quantity 1 plus 4 to the negative second times 2 times 2 is 4. All right, and then that's 5 to the negative second, which is 1 over 25, so we are getting negative 4 over 25. So looking at this, we know that the velocity is positive, the acceleration is negative, so I'm going to say that at t equals 2, the speed is decreasing because v of 2 and a of 2 have opposite signs, which is really all you need to justify that. All right, part B, find the position of the particle at t equals 0. This is actually the part where I changed the given information. Hopefully I changed it on the PDF of the problems too. All right, so we need to figure out what s of t is. So I'm going to say that s of t in general is just going to be the antiderivative of velocity. So s of t is going to be the integral of 1 over 1 plus t squared dt. That's going to be, like, you look at that, that's one of the famous ones that you definitely need to memorize. That's arctan, right? That's the derivative of arctan. So we go back, we get arctan of t plus c. Now we need to solve for c. So we know that s of 1 is equal to 3. So knowing that s of 1 equals 3, we can definitely say that 3 is equal to the arctan of 1 plus c. Now we need to know the arctan of 1. It's always good to go back and review these every once in a while. The arctan of 1 is pi over 4. So this is going to be 3 equals pi over 4 plus c. So c is gross. C is 3 minus pi over 4. It happens. There's really nothing we can do about that. So now we know what s of t is. S of t is the arctan of t plus that c value we found, 3 minus pi over 4. The question, though, is what is s of 0? So I'm going to take 0 and plug it in. So that's just going to be the arctan of 0 plus 3 minus pi over 4. The arctan of 0, again, review these every once in a while, like not continuously, but every once in a while. The arctan of 0 is 0, right? Because the tangent of 0 is 0, so the inverse tangent of 0 is 0. I'm just saying 0 a lot there. But s of 0 is 3 minus pi over 4. Pretty good. Let's take a look at the next part, I guess. We want to use a table of values for the differentiable function g of x shown above to answer the questions. Find the average rate of change of g of x on the interval from 2 to 6. Average rate of change is algebra 1 slope. We're just going to start off by writing the slope formula, right? With so it's going to be g of 6 minus g of 2 over 6 minus 2. G of 6 is 5. G of 2 is 7. So we have 5 minus 7 over 4. And then 5 minus 7 is negative 2, sorry. And negative 2 divided by 4 is negative 1/2. Good deal. Let's look at part B. Evaluate the definite integral from 6 to 12 of g prime of x over 3 plus the quantity x plus 6 over 2 squared dx. My first step on this is I'm going to break this into two different integrals because I don't want to deal with like both of these. It's like a little messy. So I will break this into two integrals. Also, I will make a slight change because the quantity x plus 6 over 2 squared is the quantity x plus 6 squared over 2 squared. So I'm just going to write the quantity x plus 6 squared over 4 dx. All right, now we have to deal with each of these separately. The first one is going to require the table. The second one, the one that I wrote in white, is you can just do it, right? So for the first one, this is a u substitution problem. I'm going to let u equal x over 3. And if u equals x over 3, that means that 3u is equal to x and 3 du is equal to dx. So 3 du equals dx. If x is equal to 12, u is equal to 12 over 3, so 4. So x equals 12, u is x over 3, so u is 4. And then if x is equal to 6, 6 over 3 is 2, so u would be 2. We can rewrite the entire yellow integral now in terms of u. So we have 3 du for dx, so pull out the 3, our bounds become 2 to 4, g prime of u du. That's good because we can just read, that's the fundamental theorem, right? So let's do the other one. The other one, I'm pulling out the 1/4, and then this one's perfect, right? Like you don't need, the chain rule didn't put a 1 there, so we don't need to reverse anything. I'm just gonna plus 1 times the reciprocal, so 1/3 x plus 6 cubed, and then we're going from still 6 to 12. So I'm not doing a u substitution on this, I'm just like doing the problem. I can evaluate that with the fundamental theorem. So back to the yellow one, we got 3g of u from 2 to 4. That's definitely 3, g of 4 minus g of 2. G of 4 is 3, g of 2 is 7. So we're going to have, okay, I'm like all over the place on how I wrote this. I don't know why I did this, but you can see at the end I like was just like, I did a bad job. So on the white one here is 1/12. I plugged in 12, I got 18 to the third. I plugged in 6, I got 12 to the third, and I'm subtracting them by the fundamental theorem. There's nothing more I can do with that. Let's go back to the yellow one. G of 4 is 3, and G of 2 is 7. I apologize that I'm like so all over the place on this particular video. It's not great. It doesn't always go great. You know, it's like, it's a lot of work to make the videos. Sometimes it doesn't go so well. All right, so overall, I would just say that my answer is the answer to the yellow integral plus the answer to the white integral. And I'm going to write it next to the original problem and just say that like this is definitely negative 12 and then plus 1/12 that. All right, I'm done looking at this problem. Let's look at the next one. Sorry that didn't go so great. Use the table of values, same table, I think. We want to evaluate the integral from 2 to 6 of g prime of 2x minus sine of pi x dx. I'm going to do basically the same thing. Step 1, I'm going to make this into 2 separate integrals so that I can deal with them. So 2 to 6 g prime of 2x dx minus 2 to 6 sine of pi x dx. Now instead of just doing u substitution on this, I'm going to try to show you how I do these by like balancing it out to try to make them perfect derivatives. So for example, with g prime of 2x, the chain rule should have given us a times 2 in there. So what I'm going to do is I'm going to put a 2 in, but I have to balance that out. So I end up with 1/2 and then 2 g prime of 2x. 2 times 1/2 is 1, so it doesn't change anything really, except it lets you do the problem. So I don't remember where I'm going from there. All right, so the 1/2, the integral of 2g prime of 2x is g of 2x. That's the beauty of it. The integral of 2g prime of 2x is just g of 2x. That extra 1/2 that's hanging out there is because we had to balance out putting in the 2. We're going from 2 to 6. I'm going to guess that I went and did the other integral next. I don't know. I did. All right, so there should have been a pi and then a 1 over pi, right? You're always saying, like, what would the chain rule have put there? And then you just put it in, but you have to balance it out. So we got 1 over pi and then pi. So I'm going to carry forward the negative 1 over pi. This is perfectly, so pi sine of pi x is almost perfectly the derivative of cosine of pi x. But there needs to be a negative sign, right? When you find the antiderivative of sine, you're going to end up with negative cosine. So we get negative cosine of pi x. If you don't like the way that I'm doing this, other than the way I'm bouncing around and don't seem to know where I'm going to write next, you can always just do the u substitution. There's nothing wrong with that. I just think it's a good idea to eventually kind of like get to this point where you can see at least the logic of how this is being done. All right, 1/2 g of 12 minus g of 4. Did I keep going with the pi stuff? I don't know. Probably. I did. Negative 1 over pi times negative is plus 1 over pi. We're going to get the cosine of 6 pi minus the cosine of 2 pi, which is really interesting because both of those are 1. So this will be 1/2. G of 12 is 9, and g of 4 is 3. 9 minus 3. And then it's basically 1 minus 1 here. So that's just 0. That whole thing is gone. So we really end up with 1/2 of 6, which is 3. All right. That was not my best effort, but I was all over the place. However, we're done. So I hope this was helpful, and good luck.